Okay, time to measure this circuit here. I've transferred these values. I put them in milliamps here, these values of resistance, of current here. I've transferred them onto this sheet of paper so we can now chip away and measure. I've also built the circuit here, well, without the power supply. I thought I might, again, after what happened last time, we might verify that this is correct. So once again, we're going to set it to ohms, and I think I'll be pretty safe just to measure the whole circuit. We were expecting about around 767 ohms, so if it's around 770 ohms, I'll be happy. And we can just go like that. It's all connected in parallel. Yep, a bit low, but yeah, it is. It's there. It's all good. Right, let's carry on. Okay, we're all powered up and ready to go. What do we need to measure first? The total current we need to measure first. So we need to again go back to this diagram here and say, okay, the total current, that is the current through which component? And it's the current through the battery. So that means you need to actually pick on the battery for this measurement. We need to go, okay, if it's the current through the battery, we need to start by disconnecting the battery. You disconnect the component that current you're wanting to measure goes through. So I'll do that. Next thing is setting up the meter. What current are we expecting? We're expecting about 11 milliamps. So we go around here. The next step up from 11 milliamps is 40 milliamps. Okay, so I'm on that. That's a good safe setting. And we're going to, remember, reconnect this battery to where it was. So I'm going to go there, not over here. That creates a short circuit. I'm going to connect back into it. Just touch one of these resistor legs, and we've got 12.2 milliamps. Might be a different battery from previous video here. 12.2, don't forget it. 12.2 milliamps. That's actually pretty good. Now, before you carry on, reconnect the circuit. Got to do that. Don't just stop there and have things unplugged. Reconnect it. I've seen so many students mess this up by actually taking things out bit by bit until they've got barely anything left. They're changing the actual circuit. So now we've got the original circuit back again, and the next thing we want is the current through the 1K resistor. Sorry, I've changed what was another exercise. So with the 1K resistor, we're expecting 9 milliamps. Now, which one's the 1K? It's the one at the top. Got to identify that. So again, we pull the leg out, one leg out of the 9K resistor. Okay, out the 9K. Sorry, the 1K resistor. Pull a leg out of the resistor that we're wanting to measure the current through. And now we're going to reconnect it back in. If you get a negative, you've just got this round the wrong way. That shouldn't be a problem. Sorry, you've got a bit of light glare there. So we're going to put, it was here, it was connected into here, so we're going to touch there again. Remember, don't go across it. Connect it back to where it was. 9.33 milliamps. Excellent. Great result. 9.33 or just 3 milliamps. Okay. Now, before we carry on, reconnect it again. If you don't reconnect it, there's going to be problems. Ooh, assuming it will go in. Okay, stay. Good resistor. Okay, and lastly, we want the current through the 3K3 or the 3300 ohm resistor. We're going to take a leg out of that resistor. It could be on the other side, by the way. Doesn't matter which side you take it out on. You just got to reconnect it into where it was, and we'll get this all lined up for your viewing pleasure, and we'll put it here. Now some students will tend to now just go like this. They'll push into that hole. That's no good. They'll push onto this. You might get it. I think the best place to touch it is nice open cable where it is, where it was, like, which is always on the end of a resistor. So in this case we have 2.8 or 2.85 milliamps. Let's do that. And 2.85 milliamps. Look at that. Whoops. Look at this. It was expected to be 2.7. That is a good set of results. Just excuse me while I pat myself on the back while whacking the table for special effects. Reason for difference, we've done all this before, but we're going to be putting down resistor tolerances. In other words, the resistors aren't exactly the same as what it says they are. The other big thing is the battery, and again, I don't think it hurts to actually write down what your battery voltage is. Now, the battery voltage always has to be in circuit voltage. I've got a wee stubborn resistor here. Oh, there you go, it's back in. So we've got the circuit reconnected again, and now we're going to quickly set it to volts DC, and we're going to measure. Remember, notice there's no other voltage to measure in the circuit. Why? Well, it's a parallel circuit. There's only one voltage in it, the 9 volts. Everything has 9 volts across it. Oh, you can't see that. I'll do that again. 9.17 volts. Okay, so I'll just jot that here before I forget. 9.17 volts. So battery voltage. Okay, not exactly, which is not equal to, in fact, hang on, I'm using programming lingo there, is not equal to exactly 9 volts. Okay, so that will be another reason for problems. Other things you could write down is multimeter error, dirty connections, etc. But yep, we've done it. Well done.